Hey guys, in this video we're going to provide a basic introduction to the classification of numbers. Let's start with a brief explanation of different sets of numbers. Let me begin with natural numbers. Natural numbers are the set of positive integers starting from 1 and continuing indefinitely. They are commonly denoted by the symbol n with a double stroke. If you want to show that by roster method, it's going to be like this. N with a double stroke, 1 and 2 and 3 and etc. These three dots is called ellipses. And it means etc. And the next one, which you've probably heard about that, is whole numbers. In other words, if you want to refer to non-negative integers, you're talking about whole numbers, which include all the natural numbers along with 0. So the set of whole numbers is like this: W, 0 and 1 and 2 and 3 and etc. And for the third one, we have integers, which are a set of numbers that includes all whole numbers, both positive and negative, along with 0. This set extends infinitely in both directions on the real line. Z with a double stroke, dot dot dot, and -3, -2, -1, 0, 1 and 2 and 3, and etc. The next set is rational numbers, which are numbers that can be written as fractions, where the numerator and denominator are integers. The denominator is not 0 because dividing by 0 is undefined. This includes integers, as they can be expressed as a fraction with a denominator of 1. Rational numbers can be positive or negative, and their decimal representations may either terminate or repeat. And of course, we have a video about repeating and terminating decimals, which you can watch it by clicking the link at the top of the video. So rational numbers that I'm going to show it by set pillar notation is Q, P over Q, such that P and Q are elements in V. P is an element in V and Q is an element in Z. And Q is not equal to 0 because dividing by 0 is undefined. Set below notation is another way to show the elements of a set. And some examples for rational numbers are, for example, we have 2 over 4, 3 over 7, each as a rational number, and 4 over 2, which equals to 2, is as a rational numbers. And you know integers are rational numbers. And another example, we have 9 over 27. And the next set is irrational numbers. Irrational numbers are numbers that can't be expressed as a fraction of two integers. Unlike rational numbers, their decimal expansions neither terminate nor repeat. Examples of irrational numbers include the square root of 2, the mathematical constant pi, and golden ratio. These numbers have infinite and non-repeating decimal representations, and maybe we can show it by this. Real numbers. X is an element in real numbers such that X is not in Q. And the last but not the least is real numbers. Real numbers contain whole numbers, fractions, decimals, integers, and numbers like the square root of 2 or pi. In simpler terms, real numbers cover everything you can find on a real line, and we show it by R with a double stroke. So let's work on a problem. You have a bunch of numbers listed up here, and we're going to classify them into different categories of numbers. The numbers are 3, the square root of 7, 2 over 3, negative 5, negative the square root of 49, 100 pi, 22 over 11, 0.13, which we want to repeat like this: 0.131313, which repeats forever, and 0.39 like this: 0.393939, which repeats forever. Euler number 1, 1.7, and the square root of 25. The first number is 3. 3 is as a whole number. And the next number is the square root of 7, which is irrational number. The square root of 7. The next number is 2 over 3, which is as a rational number. 2 over 3. Now the next one is negative 5. Negative 5 is as a integer. Negative 5. And the next one is negative the square root of 49, which is negative 7. And negative 7 is as an integer. So negative the square root of 49 is as an integer. And the next one is 100 pi. 100 pi is as an irrational number because we have pi. 100 pi. The next one is 22 over 11, which equals to 2. And it's as a whole number. And also it's as a rational number. So we have 22 over 11 here. The next one is 0.1313, which 13 under bar notation repeats forever. And it equals to 13 over 99, which is as a rational number. So 0.13. And the next one is 0.39, which equals to 39 over 99, which is also as a rational number. 0.39. And 39 is under bar notation. And the next number is Euler number, which is as a irrational number. And the next one is 1. 1 is as a whole number. And 1.7. 1.7 equals to 17 over 10, which is as a rational number. So 1.7 is as a rational number. The next one is the square root of 25, which equals to 5. And it's as a whole number. The square root of 25. It's as a whole number and integer, and of course it's as a rational number because the square root of 25 is 5, and 5 could be like 5 over 1. And 5 over 1 is as a rational number. That's it. If you have any questions, feel free to ask them in the comments. Thank you for watching and make sure to subscribe to my channel for more tutorials.